Okay, so what we've talked about so far is multiplying decimals using an area model. An area model, we've discussed that area is length times width. Emma, can you point to me where the area is in this shape?
The box.
Inside the box, correct? It's this area right here. This is my area. Okay? So, with that being said, this is my area. Okay? That is my area. Okay? So, if I were to say the dimensions of my rectangle, can I solve my area like this? Yes, I could. I could sit there and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I can't. I can find 24 squared units fit inside of this rectangle. But knowing my area has a volume, length, and width, what is my length of this rectangle? So my length would be this right here. So what would be my length? How many units?
6.
6 units. Therefore, my width would be 4 units. So if I were to see my 4 and my 6, how would I solve for my area? Asher?
You would solve your area by multiplying the 6 and the 4.
6 and my 4 together, which is again is 1, 2, 3, 4. Do you also see how I'm recounting this square? 1, 2, 3, 4, 5, 6. Okay. What do we call that when we say a 4 by 6 and we count and we multiply that? What do we call that? Anybody remember?
Area.
Array. This is an array. Okay. So I want you to keep in mind today that when we're talking about area is length times width. Now, does it matter if I say, as Asher said, he said 4 times 6. Does it matter if I say 6 times 4?
No.
Okay? Makes no difference if I say 4 times 6 or 6 times 4. Absolutely makes no difference. Okay? Yes?
Can't you say 8 times 3? Because it does the same answer.
Okay, you're right. 8 times 3 gets you the same product. But do I have an 8 by 3 rectangle here?
No.
Okay. That's why I say no, is because if I'm talking about this rectangle and I'm using it, and you do this all the time, especially people who are building a house, you're talking about area, I want a 24 square foot room, and you did an 8 by 3 and I did a 6 by 4. Is our room's going to look exactly the same? Okay? So depending on what you're talking about, it makes a huge difference. Okay? Because I'm doing this, and yours would be a... Sorry. Not anything alike, because you would be going to this way, and I'd be taking off this row. So yours would be long and skinny, and mine would be a little bit short and wider. Okay? So yes, your 8 by 3 does also make an array of 24, but when you're looking at the true area, that's not really apples to apples. Okay? All right. So today, you're going to really watch what I'm doing on this. Pardon me. So again, keeping in mind what you're doing, you're using an area model. So my end thing must make a rectangle. Okay. So, Cassie, how does that look on my recording screen? Is that okay? Okay. All right. So do not do this quite yet.
This white, you can't see the second yellow one.
Right again, it's not recording.
It's just a little bright. You can.
Okay. Stop. Okay. All right. Do I have a rectangle here?
Yes.
I have a rectangle? No. No. I got to fill it in to make a rectangle. What can fit right here? 10 cents. Okay, do I have a rectangle so far? No. I'm getting close, but what do I need down here? Do I need, can that fit down there?
No.
One hole? many hundredths do I need?
200.
All right, now, going back, again, this is my area model. This is my area model for multiple reasons, okay? And this is your decimal area model, okay? So with that being said, when you're looking at this picture, when you're looking at this picture, this is your decimal area model. Why is this area? Because I have a rectangle. If I were to trace over it, I'm not doing a very good job tracing it. Okay? And I were to take that away, I have a rectangle. Okay? So this is my rectangle. Now, not only that, is I'm covering the inside of this rectangle. Therefore, making that area. Ethan, you can't see when you're not facing me. Okay? So, this is why this is an area model for two reasons. It is a rectangle. Okay? We can find the area of a rectangle with length times width. And not only that, it is filled in on the middle. So what I would like for you to do is, I told you how your partners are going to work. I would like for you to recreate this exact thing in about 30 seconds. Do that now. Please make sure your hundredths are in the bottom right corner. Please remember, and you're creating, to make sure your hundredths are in the bottom right corner. When you're ready, put your hands on top of your head. Ooh, great. All right, moving on. Excellent job. So, everyone has your hundredths in the bottom right corner. Thank you. No other manipulatives should be out. You should have your, your rectangle in front of you. How do I know another reason this is not a square? This is a rectangle, not a square. Gabby? Good. My sides are not the same length. How do I know? I can look. So now I want everyone to put your finger at the top left, and we're going to go across. And I want you to tell me what we're tracing across. Okay, I go here. What have I traced across? What is this right here?
10.
Okay, true. But what is this whole shape?
100. 10.
One hole. This is one hole. This is two holes. What do we call this shape right here?
A 10.
10 and a tenth, right? So my length is 1, 2, and 2 tenths.
So 2 and 2.
So my length would be 2 and 2 tenths. Okay? Let's see what my width would be. Let's go back to your finger. Put your finger at the top left. Trace down. I'm going to go over one hole, 2 holes, and 1 tenth.
2 and 1 tenth.
So my length, or my width, again, it doesn't really matter because it's still 3 times 4 is 4 times 3. So I would say 2 and 2 tenths times 2 and 1 tenth. That is my standard algorithm. So just like in a regular array, so going back to what we talked about here, I would do 4 times 6, I would multiply it, or I could simply what? Count my squares. Good job. I can count my squares. Okay? So now let's go ahead and, hang on, it's going to brighten up. All right, so now what I want you to do here is I want you to count your squares here, or count what we have. So let's see what we have. What is this considered?
100.
One hole? Sweetheart, it's not 100. It's one hole, 2 holes,
3 holes, 4 holes.
All right. So what do I have here?
2
So let me do it a lighter color. So I've got a 10th, a 10th, 2 tenths, 3 tenths, 4 tenths, and you could do tenths if you want like that. 5 tenths, 6 tenths. Then what do I have here? 200. So if I have 4 holes, how many tenths? 6 tenths and
200.
so I should multiply and get the exact same thing using the standard algorithm. 2 times 2 times 1 is 2. 4, 2, 4, 2, 6, 4. What do I do when I multiply with decimals? I
Move your decimal.
tenths, hundredths, or 1, 2, tenths, hundredths. So does it match?
Yes.
Absolutely, it matches. Okay? So again, I'm multiplying using a area model. Why is this area? Because it's covering the whole shape of a rectangle. Okay? All right. Go ahead and clear your board or clear your desktop. We're going to make another one. We're going to make another one. All right, here we go. Okay, go ahead and start copying mine, please. Okay, 5 more seconds. Hands on your head when you're done. Four, 3, 2, and 1. This point, I should not see any more manipulatives being moved. Everyone's got it filled in. All right, so putting our finger at the top left. Putting our finger at the top left. What do we have going on? Ready? Let's count with me. 1, 2. Do I count this as 3 holes?
No.
I will start counting again. 1 hole, 2 holes, 1 tenth,
2 tenths, 3 tenths, 4 tenths.
So my length is 2 and 4 tenths. I would like for you and your partner to find out what my width is. Okay, Xander, what is my width? If this is my length, 2 and 4 tenths, what is my width, Xander?
2 and 1 tenth.
Excellent job. 2 and 1 tenth. Raise your hand if you disagree with that. Awesome. So what you guys have in front of you is you essentially have a 2 and 1 tenth by, because we multiply, by a 2 and 4 tenths. If you don't have that, please make sure it's done. Okay, so my standard algorithm over here would be a way to check my answer. Or I could just count what I have on the inside. So let's count what I have for my holes. Let's see. 1 hole, 2, 3, 4. All right. So let's see my tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tenths. 10 tenths. Tell me about 10 tenths. Allie, tell me about 10 tenths. 10 tenths makes a whole. So, Asher, why don't you please take all of my 10 tenths off of my display, and what is he going to put instead of that? What is he going to put? If I'm going to exchange, he's going to put a whole. No, you just took away hundredths. I don't need my hundredths taken away. Okay, I need my other 2 tenths taken off. And now he's going to put 1 whole up here. So it would be 5 wholes and what?
400.
1, 2, 3, and 4. Yes, I know this doesn't make a rectangle. I know this part doesn't. But all I'm doing is exchanging my values on here. Okay? So I have 4 hundredths right here. So what should my final answer be? What is 2 and 4 tenths times 2 and 1 tenth, Caden Cook?
5 and 400.
5 and 4 hundredths. Beautifully said. So I'm going to go over here. 4 times 1 is 4. That's 2. That's 8. 4. 4. I move when I multiply. I move when I multiply. Tenths, hundredths. Tenths, hundredths. 5 and 4 hundredths. 5 and 4 hundredths. That matches.
What if you since it's 5 and 4 hundredths and there's no 10, what if you take out the 0 and put the 4 with the 0? Would that be the same answer?
Read that to me.
5 and 4 tenths.
So I have 5 and 4 tenths? Good question. Now you know. All right. Ready for another one?
Yeah.
All right. I'm going to see if you can create this one, making sure you fill in. So up here, please do that now. Yes, with your partner.
And then here's another 100 for the 1 and 4. And then we need 4 of these. Yes. 4. Wait, why?
Hey, Mr. Cook's hands are on top of his head. Please make sure you fill them in. So real quickly, the skeleton of your thing needs to look like what Asher just made. He went from this corner, 1 hole, 2 holes, 1, 2, 3 tenths. Down this corner, 1 hole, 1, 2, 3, 4 tenths. Does this look like a rectangle? No. I cannot find my area unless I have a rectangle. So he must fill it in.
I'll get a bunch of platters.
Good job. Good job. Okay. You have. Great job. You have 1 and 4 tenths. And that's what you're supposed to have going down. But you only have 2 holes going here.
I need more. You only use these. You don't use those.
5 more seconds. You guys should be getting done.
So this was for my grandma in Washington.
All right, here we go. So Asher is correct. Okay, Asher and I did this one together. 1 hole, 2 holes, 1, 2, 3 tenths. Times 1 and 4 tenths. Okay, I couldn't leave it as is because this is area of the area model. Area is a rectangle. Okay, so right here we have a completed rectangle. We did have to complete it with these and my hundredths, my tenths and my hundredths to make it complete. So again, if I were to try write it with the standard algorithm, or excuse me, solve it with the standard algorithm, this is what it would look like. Okay? Now, for us practicing this, let's look at how many holes we have. So I have got 1 hole, 2 holes. What are the chances of us having another hole? Pretty quite likely, right? How many, what makes a hole? 10 tenths. Do we have 10 tenths? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on our paper, I know that you can't do this, but on our paper, this is how I'm going to show you this, to show that this is making my 3rd hole. Do I have any leftover tenths?
Yes, what?
1 tenth. So let's talk about what I have down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Tell me what I have here.
12.
I have 12 hundredths, right? Can I have 12 hundredths?
Yes.
Can I have 12 hundredths as is?
Yes.
No.
Tenths, hundredths, thousandths. Can I have 12 in that box right there?
No.
So what is essentially 12 hundredths, Allie?
You can make, since it's 12, you can, since a 10, it is 10, so you can keep 2 as hundreds and make the rest a tenth.
So here is another tenth. And then how many hundredths do I have left over? 2. So what is my answer? Emerson, what is my answer?
Your answer is 3 and,
How many tenths do I have? Because that's my tenth.
2 tenths.
Great job. And then finally, how many hundredths do I have, sweetie?
200.
Nice job. Checking using my standard algorithm. 4 times 3 is 12. Carry. 9, 3, 2, 2, 2, 3. I move when I multiply. Tenths, hundredths. 3 and 22 hundredths. 3 and 22 hundredths. 3 and 22 hundredths. Excellent job. Okay, this table, both of you gentlemen have 1 strike. All right, so now we're going to work on our practicing now with pencil and paper, more so than the manipulatives. Okay, go ahead for this. Go ahead and put manipulatives back. Thank you for those that have the self-control. Thank you for clearing off your desk. There's just 2 of y'all. Okay, here we go. You have this paper in front of you. Let's look at this paper. Thank you. Everyone should have a pencil. Everyone should have a paper. All eyes on the board. All right, here we go. So instead of manipulating, now I have one for you, and I would like for you to be able to tell me what this is. So I'd like everybody to put your finger at the top left. We're going to find out what my length is. So let's see, what is my length of my first rectangle?
Your length is,
Raise your hand if you disagree with Lexi. Excellent, you shouldn't be. Okay. All right, going down is going to be my width. Raise your hand and tell me what you think this width might be. Emma. Going down. Anybody disagree? Excellent job. Okay? So now I've got my length and my width. So this is essentially saying 4 1/10 times 1 3/10. All right, so let's count before I use the standard algorithm to solve it. We've got 1 hole, 2 holes, 3 holes, 4 holes. So 10 tenths. Excellent job. Let's see what I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent job. So now I have 5 holes. Do I have enough to make a 6th hole, Ethan? No, I do not, because I need 10 and I only have how many? 1, 2, 3. I only have 3 tenths. And I'm marking dots so I can count in my head. Okay? However you want to do it, if you want to put, circle if you want to do it. And then finally I have 1, 2, 3 hundredths. So looking at my pictorial representation, or AKA my area model, Grace, what would my answer be to 4 1/10 times 1 3/10? 5 and what?
3300.
So she's saying this picture is 5 3/300.
Yes.
Do I have 5 holes? 1, 2, 3, 4, 5. Yes. Do I have 3 tenths?
Yes.
1, 2, 3. And do I have 3 hundredths? 1, 2, 3. Okay, so when I multiply, I should also get 5 3300. So everyone, I'd like for you to write the standard algorithm at the top. Go ahead and do this problem. 3 times 1 is 3. 3 times 4 is 12. 1 times 1 is 1. 1 times 4 is 4. Add them up. 3, 3, 5. I move when I multiply. Move when I multiply. Tenths, hundredths. 5 3300 is what you should have also gotten.
That's why you can't see any of the words you put down on the screen.
Awesome. For recording. Thank you. Okay, everybody look at the first page. First problem. So this problem right here, this is where you're going to be practicing. Let's look at this first one right here. So what is my length on this one? I know that you're going to go, Miss White, I can't tell the difference. I know that the holes are a little bit smaller and shorter and fatter. There is, ladies and gentlemen, a significant difference between this size and this size. And a significant difference between this size and this size. So yes, these are my holes. These are my tenths, and these are my hundredths. Okay? So please know that. So please fill out the first one. Also, I'm going to call on you. Abby, I'm going to call on you on this one. And Ethan, I'm going to call on you. So be ready. Okay, here we go. So, Abby, what is my length here? 2 and 3 tenths. 1, 2, 1, 2, 3. Okay, Ethan, what is my width here going down? So how many holes? I've got 1, 2, 3 holes, and how many tenths? Good. So 3 and 3 tenths. So now you have your length and your width. Austin, let's see how many holes I've got right now. 1, 2, 3, 4, 5, 6. Austin, could I potentially have a 7th hole? How do I make a hole? I can, right? So how did you do that? So what did you put together to make a hole, honey? My 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of these put together made my 7th hole. Do I have enough to make a 8th hole, Lexi? No. Just have 1, 2, 3, 4, 5 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, what? 100. So Xander, what's my my answer to 2 and 3 tenths times 3 and 3 tenths?
7.
Great job. hundredths, sweetheart? 9. Great job, sweetheart. So 7 and 59 hundredths is what my answer should be. Next to it, I want you to do the standard algorithm with me. 2 and 3 tenths times 3 and 3 tenths. Move when I multiply.
This is confusing for me. Like, I can't tell which one is like holes and
Well, because you have to finish this off. Okay, next one. Alright, so Kate and Glenn, here we go. Let's go from this one over. Ready? So I'm going to do 1 hole, 2 holes. 1, 2, 3, 4, 5, 6. So what would be that?
2 and 6 tenths.
Great job. Kaden, going down, it's going to be
1, 2, 3 and 2 tenths.
Great job, sweetheart. 3 and 2 tenths. 1, 2, 3, 4, 5, 6 holes. Well, you think I'm going to have a chance of having a 7th hole, Delaney? How am I going to make a 7th hole? How do I make a 7th hole? How can I make a 7th one of these? There's 2 ways to make a hole. I can have 100 hundredths or Madison.
10 tenths.
10 tenths. 10 of these rods. So I can have 10 of these rods to make a hole or 100 of these little guys. Do I have 10 tenths? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure do. 7th hole. Ooh, I may even have enough to make an 8th hole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sweet. Here's an 8th hole. And I have 1 tenth, 2 tenths left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my gosh, what do? I have 12 hundredths, Ethan. What am I going to do with my 12 hundredths? I've got 12 little bitty of these guys. I've got 12 little bitty of these guys. How many do I put together to make something? I can put 10 of those together to make a 10th, right? So do I have 10 hundredths to make a 10th? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I sure do. So that gives me my 3rd 10th. And then I've got 1, 2 hundredths. So, Aiden, what is my answer to this? 3 and 2 tenths times 2 and 6 tenths. How many holes do I have? That'd be incorrect. How many holes do I have? I sure do. 6, 7, 8 holes. How many tenths do I have? 1, 2. I have 3 over here because I have hundredths. How many hundredths do I have left over? 8 and 32 hundredths. All right, ladies and gentlemen, I would like for you to work on these by yourself, but I'm going to stop you for a second. On the back, this is repeated addition. This is a practice and a repeat of what we used to do. This is repeated addition. This is a whole number times a decimal. Okay, this is repeating. Something's happening over and over. Here, this is what we worked on, 3.6. This is a decimal times a decimal. And then what we worked on today. You have just a little bit to start working on this. Go ahead. I'll be walking around and helping. Okay, so going back and looking at it, I've got 1, 2, 3, 4. I've got my fifth holes because Caden said that I need 10 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 tenths and 3 hundredths. Excellent job. All right, so now let's look at the next one. All right, let's look at the next one. So let's go with Reagan. Tell me what my length would be on this one right here.
3 times 200.
Okay, excellent. 1, 2, 3 tenths, 1 tenth, 2 tenths, 3 and 2 tenths. Okay, Jason, what is going to be my width on this one right here?
2 and 4 tenths.
Great job. Anybody have an issue or do not understand how Reagan got 3 and 2 tenths and Jason got 2 and 4 tenths? Excellent. Okay. All right, here we go. So I could write the standard algorithm, which is 3 and 2 tenths times 2 and 4 tenths. Okay. But before I use the standard algorithm, I'm going to count how many ones I have. 1, 2, 3, 4, 5, 6. Ethan, do you think I have enough to make a seventh hole? Okay, how can I make a hole when I don't have any holes left? Huh? Yeah, with the tenths, sweetheart. How many tenths do I need, baby?
10.
Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's my seventh hole. Austin, do I have enough to make an eighth hole, sweetheart? No, I do not. So I have 1 tenth, 2 tenths, 3, 4, 5, 6 left over. 1, 2, 3, 4, 5, 6, 7, 8 hundredths. So Austin, what's my answer, sweetheart? Seven holes. How many tenths do I have? 6 tenths. And then how many hundredths do I have? 8. So 7 and 68 hundredths. Doing the standard algorithm, 2 times 4 is 8. 4 times 3 is 12. 2 times 2 is 4. 3 times 2 is 6. 8, 6, 7. I move when I multiply. Tenths, hundredths, 7 and 68 hundredths. 7 and 68 hundredths. Sorry about that. Questions, comments, concerns about that? Okay, I'd like for you to turn over, and I would like for you to complete the back one by yourself. The bottom one also has one where you're just kind of filling it in to see where, if you can solve it or even use the manipulatives to make the second one. But I'd like for you to do number 3 by yourself.